So we're going to give you 60 seconds each to run through yourself, who you are, a little bit about your company and opportunity, and again, maybe your superpower if you want to do that.
I'm Sandeep Dave, founder and CEO of Data-Driven Bioscience. I'm an oncologist by training, and we've developed a new test for diagnosing cancer. So this is a really critical problem, as almost all of our lives are touched by cancer, either directly, as many of us are destined to develop it as a function of aging, and or as a function of having a loved one affected by cancer. And that journey of a cancer patient starts with a biopsy, and that biopsy that is taken as a piece of the tumor is subjected to a number of different sequential tests that can take about 2 to 3 weeks and about $10,000 to $15,000 to perform. That wait of 2 to 3 weeks can be agony. I know this when my mom went through her diagnosis of breast cancer. I know this as an oncologist, where we often spend weeks waiting for a patient to get a diagnosis, while still waiting to before we can start treating them. So we've developed a combination of a genomic test and AI software that was based on over 100,000 patients' data that allows us to automate the entire process. So we can take this process that takes over 2 to 3 weeks and $10,000 to $15,000 and enable next day diagnosis for about $1,000. So basically 10x faster and 10x cheaper.
Summarize the key message that you would tell in this very short period of time you have of your clinical and economic value propositions, and make sure you tell us if you're reimbursed or if you're just an enterprise sale that's going to just fit into the overall economics, and explain that business model. So it's really ultimately business model that we're kind of going after here, as well as the benefits.
A key starting point for our company was to make genomic sequencing ubiquitous. If you think about the technology itself on a per gene level or a per marker level, it is actually the cheapest technology out there. It is made expensive by all the complexity that surrounds it. And so we can attack that problem of complexity from 2 angles. One is to create a simpler genomic test that allows people to do DNA and RNA sequencing in one go, that allows you to kind of use a sequencer that most hospitals have but underutilize. And then we had to attack the other end of the problem through software, so that once you have the sequencing data, you know what it actually means in terms of the diagnostic test. So we had to render what pathologists and clinicians are used to seeing, but in terms of genomics. So we use genomics to render tests that they're already expecting to see. And so this has the advantage of being able to run on existing rails of hospital processes and reimbursement systems. So we're able to build on CPT codes that use genomic tests and have all this extra added value that can replace multiple different workflows in the hospital. And so the value of the hospital is that they don't need to maintain the ability to do 15 different workflows. They can combine a lot of this into a single workflow, and that makes reimbursement easier. We've also taken the strategy of engaging early with the FDA, so that we know that our test is on a path to FDA approval from the get-go. That also enables wider adoption. When I was training as an oncologist, I was one of the very first patients I saw was a patient with Burkitt lymphoma, which is a very kind of distinctive appearing cancer. These cancers have a doubling time of as little as 8 hours. So you see a patient in the morning and you see them in the evening, and the tumor, if it is visible under the skin, has visibly grown. And it is also an unusual cancer in that it is curable, in that if you diagnose these patients correctly and treat them appropriately with high-dose chemotherapy, something like 80 or 90% of these patients will be cured, right? Which is unusual among cancers, even when the cancer is spread. But the catch is it has to be diagnosed correctly, and the misclassification and misdiagnosis rates for this tumor are as high as 50%, even in clinical trials. And so we are able to develop kind of algorithms that trained on large numbers of these patients and report the likelihood that any given patient has this particular diagnosis, or hundreds of other cancer types that we were trained on. And when we went live Indiana University Hospital, which was one of our first clients. In the very first week, they had a patient that our algorithm reported as Burkitt lymphoma being the most likely diagnosis. And I was able to talk to them. And actually, that patient was referred from a community hospital where they were given an entirely different diagnosis. Right? It was really kind of fun and gratifying to see kind of the whole thing come a full circle. This was kind of one of the things that inspired me as an early oncologist. And the very first time the test was run in patients after the validation process was a patient in whom the very problem that we had sought to solve was confronted and solved. So that was kind of instant proof to the hospital and the providers that this was a test worth using in all their patients.